In this session, we're going to talk about real-world examples. This is a really simplistic comp where we have a phone screen that needs a screen burn. They're coming from different places. One is camera native, one is just an image pulled from the web. So the first one we're going to kind of walk through is the nuke managed way, and this is kind of using some explicit tricks. If you haven't seen the order of operations session, I would maybe start with that one before you dig into this one. We talk about a lot of these concepts in that one, and it'll make a little more sense as we walk through this shot. But here we go. So here we have our camera native plate. Turn off my IP. We're using an expression inside nuke to get it to vlog, because this shot in nuke managed, vlog isn't an option. So the only way to properly manage shots that don't have a profile in nuke default is you have to either use an OCIO config that has them, or you have to make them, via expression node, or use a LUT file. So that's what we're doing here. So we'll flip this back to raw. So here we have our vlog converted to linear camera native. We have our sRGB color chart that we're going to comp into our phone screen. We're doing a little work. We're despilling. We're pulling a key. We're punching that out of our phone screen and comping that in. So here we have a comp. It's in camera native gamut, and it's worth noting that this isn't how it's going to be seen when it goes into online. In online, they'll have likely a camera native timeline, but that will be converting from the camera native timeline to their displays appropriately. To replicate that, what we're going to do is use an IP or a shotlet. In this case, it's just a simple matrix that goes from vgamut to sRGB. And now we can see what that shot would look like more managed. But a lot of times artists might not see it that way. They'll look at it here, and then they'll look at it through a shotlet or a showlet, and it'll look the way it looks. That typically matches dailies, which could have a number of different transforms going on. But if we wanted to see it fully without any creative choices, you could use a matrix to do that gamut conversion for you. So here we can see there's a little bit of saturation mismatch now that we've actually moved this into correct space. And we'll really see that in the next example. So the next example is camera native gamut with matching gamuts. So in this case, we have our camera native vlog, vgamut, and now we take our sRGB plate and we apply an sRGB to vgamut matrix. So you can see that's desaturating everything. We then work through our comp. So now everything's in a matched gamut. And when I turn that off, you can see the difference in saturation on the phone. And if we were to turn our... So here's the difference without the IP on. And if we turn our IP back on, you can see everything feels a little more correct in terms of saturation. So that's camera native with matching gamuts. And this is a very workable way and a really quick workaround if you're in a camera native gamut workflow or a nuke default workflow. You can use this to convert, and that way you don't have to worry about losing any data in terms of clipping, because the next method is a similar process, but in this case, instead of converting our element to camera native gamut, we convert our footage into our basically element gamut. So in this case, we're taking our vgamut and converting it to sRGB. So now you can see the image sweetens up, and it actually looks pretty close to what it looked like on the day. And now when we comp it, everything lines up pretty well. The problem with this is it will take these saturation values, and you can see it here in the green. We're getting negative values in our red and our blue. If we were to clamp this, it would actually clip our gamut of our original footage. So even if we undo those gamut changes, so we go sRGB back to vgamut, we would have actually lost some color in doing that. So I don't recommend this. I've done it. I've worked whole shows like this in the past where we basically made a gamut sandwich and converted everything to display gamut so it looked correct on the screen. In real world testing and testing it versus camera native versus like Ace's CG working space, this will help with some shots, but this isn't my recommendation. But it is another way to do things. I just wanted to show it for posterity. The next, and this is really what's happening when you're working fully managed with Aces, is you would take your footage, you're in linear camera native, you can then go V-gamut to Ace's CG, and similarly you would take your sRGB plate, or your sRGB element, and you would also convert it from sRGB to Ace's CG gamut. Then you would do your comping, and in this case, just like we needed a viewer process to properly see it, you also need a viewer process on this side to go from Ace's CG to whatever your display is. So in this case, we add our sRGB IP, and now we're seeing our image in native space, native to our display, and it looks the way it should look. And again, this is basically replicating a Ace's CG working space. Pretty straightforward. Couple little gotchas, like you have to use an IP to actually see it correctly. Ace's CG feels kind of weird in terms of the color if you're not using any kind of input process. But that's a little quick workaround. Shows a few different ways to work the exact same shot the same way, but using different color management schemes. So that's in Nuke default. If we want to work Aces 1.2, we'll flip over here. So here we're in Aces 1.2. We've set our working space to Ace's CG. It's a little simpler in that we just pick our input transform, say input Panasonic Vlog V gamut. For our sRGB element, we pick utility sRGB texture, and now everything is coming in correctly, and then under the hood, Nuke is piping everything into Ace's CG. We do all of our comp work, and you're looking at it, and it's like, well, that feels a little different than, let's say, like this guy. Oops, wrong one. So like if we look at this and we flip back to our 1.2, you can see everything is a lot darker. And this was an issue for a lot of folks using Aces 1, Aces 1.1, 1.2. Our viewer process is set to sRGB, so that makes sense. But what's actually going on under the hood, this sRGB is not the same as the sRGB in Nuke Managed. What's happening in Aces 1.2 is this process has tone mapping applied. So it's got a little bit of a knee and a little bit of a shoulder where it's pulling all those highlights down, and it's kind of pushing some of the shadows down as well. So we get this image that's much darker, and there's a quick workaround. The best workaround is to actually modify your Aces config, your OCIO config for Aces 1.2, and just add or change the sRGB viewer process to sRGB texture instead of output sRGB. And if you look at an OCIO node, let me open a fresh one. The space we're actually seeing when this is set to sRGB is output sRGB. That is the tone mapped version of sRGB. We don't want that. So we can either use a config to make a modification and add another process, or just change this one, or you can do a little quick hack where you basically, either as an IP or as a separate fork that you just use for viewing purposes, you would go from your working space, because remember, all your math is happening at the working space. So we want to start there, because that's where things are actually at right now. The viewer is a separate process. So we go from our working space, which is Ace's CG. We tell it we want to go to utility sRGB texture. we add another config or another color space node where we set the in as output sRGB and the output as ACES CG. Because basically what we're doing is we're mapping that sRGB texture to output sRGB, which is our actual display process. So we're functionally just kind of bypassing the output sRGB. And then we can view things through the bottom of that little stack. And now you can see when we bounce back and forth, they look exactly the same. So that's a quick trick. You can do it like that, or you can group those together and make them an input process. And that way you can toggle that on and you can see tone mapped sRGB and untone mapped sRGB. And that's functionally what's happening in ACES 1.3 is untone mapped matches this. The tone mapped SDR matches this. But all of our spaces are actually managed a little more friendly, which will take us, we'll go ahead and jump over to ACES 1.3. It's the same process. We set all of our inputs to what they actually are. We do our comp work. And here, my viewer process is set to untone mapped sRGB. So now, if we check that against our original, you can see that our color is lining up 1-to-1. Looks exactly the same in 1.3 as it looks in Nuke default. And then if we go in here and turn our IP on, you can see that in 1.2 it looks exactly the same as well. And again, that's the point of ACES, is we want things to look the same device to device, suite to suite, facility to facility. And here we're seeing the same image look the same way. And that's really important. But back to 1.3, there's no tricks here. It's just set it up how it is, use untone mapped if you want that sRGB display. If you are working footage that's like Alexa Log C4, which has really high highlight values, these SDR profiles. So this is the one that matches the, if I turn my IP off here, you'll see that the SDR tone map matches the sRGB default in 1.2. Just a couple quick little tips. That's how you can work that same shot across 3 different management styles. And there's a lot of options. Again, in testing, I find that the ACES CG working space is the best. We've ran a number of tests, especially on keys, shots with big blue screens, big green screens in the background that are making, a lot of spill, a lot of edge detail that you're having to resurrect through transparency. My personal experience, and using a few different key methods as well, and having some other artists test for me is, in addition to that, is that ACES CG is generally a decent space for doing color sensitive work. You can squeeze a little more juice out if you're using like a linear sRGB working space, but it does run into some issues with fringing, especially where you have things roll off, like on this color chart, for example. We probably won't be able to see it, but one of the things I've seen is that if you have a really bright saturated color that rolls into black, you will occasionally, you can actually see it'll roll negative on the edge. And when it rolls negative on the edge, you'll get some banding and you'll get some things that are kind of hard to fix in linear sRGB space that aren't as hard to fix in ACES CG. Meanwhile, you get a screen, a color that's a little more keyable than if you just left the footage in camera native gamut. All right, so that kind of wraps up a real world example through the different color spaces.